Welcome back. I hope you are feeling awesome. As a part of this lecture, we'll understand actions in RDD. By the way, we have already seen actions in data frames, isn't it? Can you just recollect what are actions? An action instructs the Spark to compute a result from a series of transformations. So what you do is, as a part of the transformation, you build a logical transformation plan. But for computation to happen, for calculation to happen, for manipulation to happen, you got to trigger an action. I hope you recollected what is action is. We have seen actions in data frames. How the actions in data frames are different from actions in RDDs? They're pretty much same. The way you have done the actions in data frames, in the same way, you have to specify the actions in RDDs to kick off the specified transformations. What exactly actions do? Actions either collect the data to the driver, or it will write to an external data source. We have already seen that in data frame, but we are kind of revising that. We are doing the actions on RDDs. What are the actions in RDDs? One of the action is reduce. The second action is count. The third action is first. The next action is max and min. And the reason we kept this first is we have already seen take is also an action. These are the different actions in RDDs. Let us see them one by one. Remember, we have already gone through map and reduce. If you have gone through our Hadoop ecosystem lectures, in that we covered the map reduce in detail. In the reduce phase, collation used to happen, aggregation used to happen. The reduce action in RDD, more or less similar. What it will do is, it will reduce an RDD of any kind of value to one value. It is pretty much same. Here, by using a reduce method, we can specify a function to reduce an RDD to one value. That is what reduce is doing. Let us take an example here. If you see, we are using one function here, that is a anonymous function, that is a lambda function, right? We are using a reduce here. It is a reduce method. If you observe clearly here, there is a range from 1 to 21, that is from 1 up to 20, the numbers will be there. All those numbers are taken one by one and they'll be reduced into one number. In a way, it is summing up all the values from 1 to 20 and gives the sum of all these values. This is where you can use the reduce. Let us take an example here. Here in this function, the name of the function is word length reducer. In this, what we are trying to do here is we are trying to find the word which is having the maximum length in a particular set. As a part of the reduce method, we'll use this function. All the elements in this RDD will be checked one by one and we'll get the one word which is having more length, or a one word which is having the maximum letters in that. One of the important aspect is reduce operation on the partitions is not deterministic. What does it mean? So there are something called probabilistic and deterministic. When you say deterministic, we will always get the same answer no matter how many times you repeat the same algorithm or same calculation. But in this case, we are saying reduce operation is not deterministic. Means when you are polling through the RDD, which is having number of words, and use a reduce operation, you may get one word, for example, let us say spark sometime, and one more word another time. Means it is not guaranteed that you will be getting the same word all the time. So that is the reason reduce operation is not deterministic. So you got to be careful. You want to really get the same answer all the times, immaterial of how many times you execute that. The next action is count. Count is, we know that it's like self-explanatory. What it does is it will count the number of rows in the RDD. For example, in this case, words is an RDD where we'll have a set of words. It will count all the words in an RDD. The next one is count approximate, right? We have already seen this in data frames also. What count approximate does is it will approximate the count, means it's the approximation of the count method. We have to provide two arguments here. One is the timeout and also the confidence. Timeout means, let us say if you give some 100 milliseconds, it will try to approximate within that time. If it cannot be approximated, it will in a way return the inconclusive or incomplete results. The next one is confidence. What does confidence means? Confidence is the probability that the error bounds of the result will contain the true value. Means if you give the confidence more, the value of the confidence should be between 0 and 1. If you give more value like 0.95, then the approximation will be more accurate. So for count approximation, you have to give timeout and confidence, these two arguments. Let us see an example for count approximation by using a count approx method. So here you can see the words is an RDD here, and we are using a count approximate action, and we are specifying timeout that is around 400 milliseconds, and we are providing 0.95 as a confidence. This is how you use the count approximation method. The next action is count approximate distinct. As the name suggests, it is approximating the distinct values in an RDD, right? So we have to pass an argument here, that is what is the maximum error allowed while approximating the distinct values in the RDD. The next one is count by value. What it does is it counts the number of values in a given RDD. You got to be careful with this guy, because it counts the number of values by loading the result into the memory of the driver. So this method need to be used only if the resulting map is expected to be small, because as we already mentioned, the results are loaded into the memory. If the results are more than the driver can handle, there is a chance that your system may crash. So you use the count by value with utmost care. The way you can use it is, this is the name of the RDD, then you can go with a count by value. The next one is count by value approximation. This is just extension of the count by value. Instead of counting the accurate values in an RDD, we'll approximate it. Okay. The same thing, the way we have already seen the approximation in the earlier case, that is count approximate. Here we are approximating the count by value. Okay. Again, we got to specify the two things here. One is the timeout and also the confidence. This in the similar lines of approximating the count. The next action is first. As the name suggests, it will return the first value in the dataset. Here we have an RDD and this is the first value. The next important functions, which are self-explanatory, min and max will return the maximum and minimum values in that particular RDD. For example, here we are having an RDD from 1 to 10. The max will return the maximum value in this RDD, that is going to be 19 because 1 to 20, and min will return the minimum value, that is going to be 1. It is easy peasy, right? The next important thing is the take, which I have been already using multiple times. Take and its derivative methods take the number of values from your RDD and display it to you. How does it work? The way it works is it will first scan the RDD partition. Then, using the results from that partition, it will estimate the number of additional partitions needed to satisfy the limit. Means when you take, it may not scan through all the partitions in RDD. It will first scan the RDD partition, then go ahead and estimate the number of additional partitions. It will display the results for you. And we do have many variations like take ordered and couple of other things, which anyway we'll be seeing in the next slide. We do have take ordered and top. This is the RDD which we have already seen. We have been using the take multiple times. If you have already gone through the hands-on sessions, these are the some variations of take on RDD. Wonderful. We have seen actions on RDD. We'll see all these things as a part of our hands-on exercise. Thank you.